Good evening, uplookers. Those of us who are looking up at night. I am about to start an imaging session and I'm trying to find a camera that works. I made some changes to my mount. I rebalanced it, or to my telescope, and I rebalanced it. So I'm going to need to calibrate. And I thought I'd do a video that shows how I calibrate Phd2 and just how I go about it. So let's get started. I'm going to bring up my remote setup and let's see if I can find it. There we go. And currently I have chosen a guide star. It's HR5679. I have no idea what it is. But what I did earlier in the evening is I brought up my planetarium software, which is Sky Safari Pro, and I picked this star because it was near the celestial equator, and I knew it was going to transit about the same time that I was going to start my imaging session. So, and it's in the southern meridian. So on the celestial equator, southern meridian, let's see, it has a deck address of 00, so it's right on the it's right on target, and it's just crossed the southern meridian, so I'm not going to have to worry about a meridian flip. I thought about picking the star a little earlier, but the skies just don't get dark enough. It takes 10 or after right now before I can start anything in southeastern U.S. So let's go back to our setup, and still need to get to our setup. And let's go ahead. Before I do that, I'm planning on imaging NGC6995, which is the Eastern Veil Nebula. And this is the outside setup. I'm only going to use one telescope tonight, and that is this Vixen 625 millimeter refractor, and I have a Moonlight electronic focuser, a 7-position 31 millimeter filter wheel, and we'll be doing narrow band, so hydrogen alpha, oxygen 3, and sulfur 2 images tonight. And then I have a ZWO ASI 1600 mm Pro camera. So in fact, I have the 1600 mm Pro on this kit, and on this kit, which is the Stellarvue SV70T, an even wider field refractor. So let's head back to our software, and let's go ahead and I'm using, by the way, Sequence Generator Pro to image. It is my acquisition software, and if I check the planning tool by clicking here, I can see that my target, this is where we are currently, and it's already gone through a transit, which we knew, and so it's I'm ready to go visit it. So I'm going to slew to it, and let's bring up our outside camera. And this is a surveillance camera. I have 2 of them outside, one on the sky and one on my kits. Since it's at the celestial equator in meridian, this is going to be the weights in the refractor are going to be pretty much horizontal, perpendicular to the mount. Alright, we're in the general area, and I'm going to center, which is plate solving. What you saw there, while this is plate solving, I also have another planetarium software program that I used. This is the Cartes du Ciel. I have no idea how to speak French. That's as good as I can do. But my mount is right over here, and it's in the process of hopefully it's in the process of plate solving, although it really doesn't have to plate solve. The first attempt failed. I'm 141 pixels off in right ascension, and I'm 29 pixels off in declination. But it'll be in here somewhere. It's probably this star here, and it didn't move very far, so I'm guessing it's going to fail the second time. But I'm going to go ahead and abort it. It succeeded, so let's. I don't think it succeeded because this has to be the star, and it's definitely not centered. But that's fine. I'm going to bring up Phd2. It's already connected, and I've connected the equipment. This is the guiding software that I use, and this right now I'm showing the stars in as they're being looped using a Lodestar Starlight Express guide camera. And the first thing I want to do, though, I have a ridiculous amount of backlash in my mount. It's an Atlas Pro EQ-AZ, and I am using EQ-SCOM. So this is my virtual hand controller. I'm going to put this on 2. I'm going to change the guide exposure length to 1.5 seconds, and I'm going to nudge this west, and you can see the guide scars moving, and I'm going to nudge it north. And really all I'm trying to do is to take the slack, slack or backlash out of the mount. I haven't seen the mount really. There it's moving north. Okay, so west and north, and hopefully we got the slop out of the gears. So I'm going to start the selection of stars for guiding, and if I click on guide here to start guiding, it will, because I have it programmed to do that. But I'm going to hold down the shift key and click on this, and it's going to say, are you sure you want to force a recalibration? And I do. So I wanted to check the SNR of this. The SNR of the star is 41.7. I'm looking at the signal to noise ratio. It's important that I get a decent SNR to do guiding or calibration with. And this shows the star moving there, and it shows the star moving here as it's sending pulses. Phd is sending pulses to the mount to move it, and it's measuring how far it moves with each pulse. And as it goes through this process of calibration, watch it fail since I'm recording this. And it does from time to time. you get these insane messages that your star didn't move enough, and you find either you have picked up a pixel that you're trying to guide on, or you really just, in my case, when that happens, I just restart I shut it down, I restart Phd2, I reconnect my gear. If I need to replate solve, I will, probably won't, since there's stars in the field of view, and that's all that matters. And normally that really just fixes it. But I also make sure I pick that the PhD picks another star to calibrate on. So, but it is important that for me in my mount, and it is definitely it's not a high-end mount. So it comes with its imperfections. It will guide fine, not great, but when I'm doing this kind of wide field imaging, I can manage with the RMS errors that I am getting, which are sometimes pitiful. So at any rate, we've moved the mount south, now it's moving it back north, and we're getting close to having a finish. So now we're going to start guiding. I want to go up here to Tools, and I want to review the calibration data, and I want to compare the RA rate with the deck rate, and they're close. That's good. I can see where in declination that I've got some issues because it was returning the star back south. So, but as I said, I know I'm going to have issues. So this isn't good. You know, I'm at 192 RMS right now. Now, I do know this. It settles down. I don't know why it has to settle down, but it will settle down. All right, well, we do have a successful calibration. We are guiding. And before I start imaging, I want to run Guiding Assistant. And what I will do is go to Tools, and I'll drop down to Guiding Assistant, and it will say that the Guiding Assistant will disable the guide output and allow the guide star to drift. So that's what we're going to do, and we're just going to let PhD start running its magic. And what it will ultimately do, it'll make several recommendations. It's going to evaluate the scene conditions and suggest the exposure time range I should use. It will also suggest the minimum move settings that I should try, and it will also allow me to look at my backlash and see what's cooking there. So far, as it's settling down, it's showing my polar alignment area to be in the be unacceptable. I don't think it's that bad. I think it'll settle down even lower. It did 3 days ago, and I haven't. And these are permanent setups. I haven't done anything with the mount, but I need to take some time and go out and connect PoleMaster and do a polar alignment. So here we are. I'm just going to let this run for a few minutes, and when it's completed, I'll get back to you. Okay, the mount has completed the guiding assistant, and the polar alignment error improved, but it's still, really it is unacceptable. It's unacceptable at 5.7 arc minutes. So I'll have some deck errors. I'll have some stars that will show that polar alignment error, and I'll have some obvious drift. It suggests that I set the right ascension minimum move to 0.10, and I'll accept that, and the deck to 0.15. I'm going to accept that. It says that your polar alignment error, that could be improved, and I'm not going to fool with that tonight, but before I image, I won't be able to image again until Sunday night. We're promised some good skies Sunday and Monday night. So I'll go ahead and polar align this and get this corrected or get it improved. And it suggests that I use an exposure time that's making a change down here between 1 second and 3 seconds. So let's just split the difference and let's put it at 2 seconds and see how it works. And I may try it at 3 seconds to see if my RMS numbers improve. I might try it at 1 second. And it suggests that I start with backlash compensation to be at 2090 milliseconds. So I'm going to go ahead and accept that. This is the backlash graph, and as you can see, I had some issues in south side, so that's to be expected. All right, well, let's clear this out. We now have calibrated the mount, and we have, I'm going to reset this. We've calibrated the mount, and we have ran the guiding assistant, and we've accepted the minimum move of 10 and 15 for deck. We've made some adjustments to the backlash compensation and accepted the values that were suggested by Phd2. I don't argue with them, I just accept them. And our RMS is somewhat improved. It is, rather than 190 something, it's around 103. And again, not great, but it's better. In fact, we had a deck went crazy there and it moved it up to 1.5. I spoke too soon. But I do want this to level out. However, I'm not going to let it level out here. It looks like something crazy is going on right now. What I imagine is going to happen is this is going to buy me a trip out to the mount and double check my cables to make sure that they're where they're supposed to be and I don't have anything dangling. We really don't have any wind. It's hot, humid, and still out. The temperature is in the, it's about 80 degrees out. Humidity is 99%, and it's sticky, and there is no breeze. So I don't have a wind problem, but it's possible I have a cable problem. At any rate, I'm going to bring up my camera and make sure that it hasn't signed off, and then we're going to go back to our acquisition software and go to our target and see if we can get our imaging session started. Again, we're going to the Eastern Veil, which is 6995, and I'm using a Vixen 625. This is the deck and the RA address. And so this target has reached an altitude of 28 degrees, which is really, really low in the sky for imaging, but I'm not imaging over lights. I'm imaging in a darker area of the sky for my observatory. And plus I want to take advantage of the time I have tonight, and I want to crowd in about 4 hours of imaging. I'll probably stop it because by the time it does a meridian flip, we're going to be working on the sunrise and the effects of that. So let's, my camera in an effort to save battery power, is set to timeout, and it keeps flashing back up and asking me if I want to let it sleep or keep it alive. And each time it does that, it enters this enters the picture. So it's an aggravation. We're about to end it because we won't need it anymore. So I want to go ahead and slew to the target, and I will need the camera now. So let's take a look at the camera while it's going to the target. And I'm kind of looking at my cables. The only one that might be giving me a fit is the main cable that comes out of the camera, and it supplies, it's my power and my data cable. I use ultimate power boxes for my kits, and I don't know why it's still dangling out here. I may have to go check it out. See how low I'm shooting in the sky? But again, I'm shooting over a part of my landscape that is into the darkest part of a 360 degree view. And I do have a 360 degree view. That's the darkest area in the north, and to the north and the east. Okay, it has made it, and I am going to have to go check cables. I'm going to go ahead and center, which is Phd2. And I got a message from Phd2 that wasn't aware of me planning on slewing off the target, telling me that guiding stopped, and it had gone back to 114, by the way, which is still not good. I like to be under 1, and I'll fiddle with it until I do get under 1. I'm going to stop this. I'm going to start looping again, and then I'm going to auto select a star, which I'll have to do again. But let's go back and check our plate solving, and we ought to be getting close to finish. Ooh, we're way off. We have 611 pixels off in RA and 157 pixels off in DEC. And I see some faint nebulosity. I doubt it's going to be visible on YouTube, but I see some there. Okay, we ran a success. We're 6 pixels off in RA and 8 in DEC. So let's go ahead and let's start the guiding. And we have an SNR of 65.2 at 2 seconds. I'm going to clear out my but I want this to run full off, but that's good because I have several things I want to do first. One is I'm going to go ahead and start the imaging session, and we're going to run, it will automatically start focusing and run the focuser for me. Setting the HA filter right now, and it's starting the focuser. It's taking a 23-second image because this is narrowband, and we're going to start with the hydrogen alpha filter. It's a must that I set this for longer exposures. So that just means it takes a little longer to run the autofocus routine. So I can see some of the faint nebula in here, but you see the defocus stars, we can go ahead and sleep now. That won't bother us again. Once it goes to sleep, it's done until I start it back. But this automatic focus routine deliberately defocuses the refractor or focuser in one direction, and then it moves based on step sizes that I set. It moves, in my case, 70 step sizes towards focus, and it continues to do that. This is the second exposure. The first one had a half flux radius of somewhere probably around 7 and change. It moved the focuser back towards focus, and the second one is about 5, and now we're at 3, 3. And so ideally you get a V-type looking curve, because it's then going to defocus in the other direction. Once it gets back to the starting point, it'll defocus in the other direction, and it'll create this V-curve, and at the intersection of the V-curve is where you're going to find the sweet spot for the hydrogen alpha filter for at least this hour or this minute. As the temperature drops, and at 80 degrees, it's going to drop down to like 68, 69. So that's pretty significant. It's hot. It's been hot, and then it's going to get down into the 60s. So I'll be refocusing about every 15 minutes for a while, and kind of keep my eye on the temperature, which I can do. I can do by looking over here at the environment tab, which won't be active while I'm focusing. Or I can just go over to my environmental graph on my Pegasus power box, and I can watch this blue line, which is the temperature, and as you can see, it's starting to drop some. The red line is the relative humidity, and when those two intersect, you can almost count on having dew and wet grass and kind of what I call heavy air. It's so humid, the air just gets on your teeth. The temperature now is 75 degrees, and the relative humidity is 99%, and it's short of raining is what's going on. Okay, as you can see, we went back to focus. Now it's defocusing again in the other direction, and we'll take a look back at our curve, and we're getting a V-curve that looks pretty good, and it's going to take another 23-second exposure. So far, it's suggesting, based on what it has now, with a quality rating of 96%, that the focuser at position 7955, that's the steps from 0. When the focuser is racked all the way in, then if you back it out 7955 steps, then it will, or 7950 now, it's reset that, it will be at what it feels like is a sweet spot. It's completed it really. It's taken a validation exposure just to confirm that we have a good HFR, and we'll find out. Right now the half flux radius at the last exposure was 8.61, and that's defocused. Okay, so at position 7950, which is what it's set at now, 7950, it's moved it there. We have a half flux radius of 1.21. And we can work with that. As you can see, our stars are pretty tight. And you can see the nebula because I did the 23-second exposure. And because the Phd's been off for a few minutes while autofocus ran its routine, it's plate solving again. It's going to recenter the target, and then it's going to start imaging. Because it is as hot as it is, I'm only cooling the camera at minus 15 degrees Celsius. So right now it's 75 degrees out, so the camera sensor is at 60 degrees. It's taken 48% of the capacity of this camera to do that. And during the summer, I even go to minus 10 and just work with the noise. Okay, we're starting. Phd started back up again. It was started by Sequence Generator Pro, which stopped it, and so it started it back up. And now it's begin the imaging session, and we're currently, if you look down here at the bottom in this green area, you can see that we're taking 240-second images. I've set up in hydrogen alpha to take 20 240-second images, and then it's going to change filters, and it's going to take 20 240 O3 and then 20 240 S2, and which is a total of 4 hours of imaging time. That's not enough. That's all I'll be able to get tonight, and then Monday night I'm going to add another 4 hours, and Tuesday night I may add another 4 hours. But I also plan to open up the other scope Monday night. I'm going to stay in this record mode until our first image comes in, and then I'm going to sign off. This environmental tab will tell you what my dew point is and what the temperature is. As you can see, the temperature has already hit the dew point. I have, this is my telescope information over here. It's something that I like to have. You can choose other options to have in your opened Windows area, but I keep my focus control, my filter wheel, my image history, and camera information on cooling, my histogram. Phd actually shows a mini graph that's really just a smaller version of what Phd is doing over here, and so I don't have to go back and forth if I just kind of keep an eye on this for some weird spikes. This is what I use for framing and focusing. And we're going to take, actually I want to show you how I find my targets. I go up here to Tools, and I go down to Framing and Mosaic Wizard. And let's say I want to image M101, the pinwheel galaxy. And I just type in M101, or I can browse my images, or I can type in the RA and DEC address myself, and I just click Fetch, and it brings up a picture. Usually it's color, but it's only color the very first time you use it. If you do any other fetching, then the subsequent images are going to be black and white, that's just fine with me. And so I draw a box around it, and by the way, it's already given me my first hydrogen alpha image and downloaded and started the second one. So we're looking pretty good so far. The stars look pretty tight, although I need to zoom up really to see for sure. Okay, let's go back to my framing. And when I try to click on the box, it brings up the exact field of view of my camera and refractor combination, because I put in the image scale information. I enter that when I create a profile for my kit. And under the camera, I put in the pixels on width and height. I calculate what the image scale is. You can find that multiple places online. The readout of the camera, which is not that low, and the angle of the camera, which was already calculated from prior imaging sessions. I do not have a rotator. And so knowing that information, then when I do search for an image, it will show me what my image will look like in my field of view. And then I can say create a sequence, and I give it a name. I'll probably add here the date, the telescope that I'm using, and I may even put Pinwheel Galaxy because that's the other name for it. I can either append to the current targets, or I can replace the target that I already have, which I don't want to do. And I don't want to rotate the camera, so I don't have a rotator. I click OK. And then what it will do is it will give me a success, and it's added M101. And it has put the RA and deck address in. And if I click on planning tools, I can see where this galaxy is already gone through its flip, or gone through transiting, and it's on its way. It's at 55 to 61 degrees. I'm looking right here. It's at 61 degrees in the north, and it's going towards the horizon. But I'm not going to image this. I'm going to go ahead and, in fact, I'm going to delete it. It won't let me delete it while I'm imaging, so I'm not going to stop it. All right, let's go back to we'll go back to framing and mosaic while I'm on the subject. If I had a target like, let's say, M. Well, let's go ahead and take this target, NGC6995, and let's increase the field of view by 15 degrees. And I'm going to go fetch. And let's give us some real estate to look at. And so I just made a liar out of me. I said a while ago that I won't get another color images once I've done this, and I've never had one except the very first time I used this. So let's just say I wanted to image this whole area here. Well, then I can draw a big square, and using my telescope fractor scale combination, I could take 36 tiles or pictures. I have the overlap already have a 20% overlap, and I could build a mosaic taking HA, O3, and S2 of each one of these, and which all could be blended together in your software choice. For me, it would be PixInsight, into one huge, monstrous image. So we'll cancel out of that, but Sequence Generator Pro makes it very, very easy to do mosaics and move the camera for you. And by the way, when you click OK and you set it up, it creates the sequence imaging session for you. And after you fit, and it, let me go back up here, you'd have 1 through 36 events. Actually, it'd be times 3, because you have 3 events per frame, so it'd be 36 times this. And obviously you couldn't do all that in one night, and so you would just start your marathon imaging of that region of the sky. And of course, I wouldn't advise trying that unless you live in a place where you've got clear skies almost every night, or you'll lose interest in it. That's kind of what's happened to me, and I get tired of the target, move on to something else. I've had so many incomplete mosaics that I set out to do. Obviously, I've never done one that big, but a 4-panel mosaic, that's still a lot of work. But a 4-panel, say, or an 8-panel, that can cover a lot of real estate with my wide field telescopes. Now, I also have an edge with a hyperstar that I can use, and another older Celestron, the old black tube. I have that I can use for planetary, and I do some deep space with that, but mainly just the smaller galaxies and some of the planetary nebula that I really can't get. By the way, I noticed something here. I'm getting some crazy spikes in DEC, and I got one in RA. So I'm gonna call this a day, and I'm gonna walk out to the mount and see where that cable is, and I have a sneaky suspicion I need to move it. It's probably hung up on one of the antennas that connects to my Wi-Fi, connects my laptops that are outside with my inside desktop. Okay, folks, it was so far pretty uneventful, but you get a feel for how I use Phd to calibrate and then run Guiding Assistant, and then how I might set up an imaging session or perhaps a mosaic with Sequence Generator Pro. Both of those software programs make it possible for me to do things I couldn't otherwise do. And then PixInsight for processing is just it's just a doggle to use. It's just awesome software. I enjoy processing pictures when you have software as powerful as, say, this or Photoshop, or PixInsight and Photoshop. They're awesome. All right, last but not least, this is the setup I'm using right now. This is the far telescope, not the one that's covered. That's a solar telescope setup. But the far one is the Vixen, and the closer one is the Stellar View. And then that's pretty much it. So have a great evening. Have a great rest of the week, and hope clear skies bless all of you.